Hello class, this is Mrs. Gallegos. Today's tutorial will be on reaction types. There are 4 different types of reactions. Synthesis, which like the name suggests, is 2 compounds or elements reacting to form 1 compound. A decomposition reaction is the reverse. I have 1 compound, always a compound, decomposing into elements or compounds. A single replacement reaction is an interesting reaction. I'll have an element and a compound that forms a new element and a new compound. And what's the replacement? Well, this element simply replaces one of the elements in the compound. And so at the end of the reaction, C reacts with AB to form A plus CB. A double replacement is similar to the single replacement, but instead of having an element in a compound, I start out with 2 compounds. And then those components of the compounds will switch places. So if I have a compound made out of A and B, in the end that compound will then be A and D. If I have a compound made out of C and D, the D and the B will be switched. And so we have a replacement going on between a compound and a compound to form a new compound and another compound. I can use this skill, this understanding of the 4 different reaction types to identify an actual reaction. So if I react calcium oxide with water and form calcium hydroxide, what type of reaction is it? Well, this fits the symbolic representation of a synthesis reaction. 2 compounds reacting to form 1 new compound. So this is a synthesis reaction. Here I have ammonium nitrate plus dinitrogen oxide plus water. So the ammonium nitrate yields 2 new compounds. So when 1 compound yields 2 compounds, that would be, follow this AB yields A plus B symbol. So this would be a decomposition reaction. Here I have calcium hydroxide reacts with hydrochloric acid or hydrogen chloride to form calcium chloride and water. So here I have 2 compounds forming 2 new compounds. So this follows the symbolic representation of a double replacement reaction. When I was in high school, my chemistry teacher used to call this the Fred-Wilma Barney-Betty reaction. So at the end of the reaction, Fred is now paired with Betty, and Barney is paired with Wilma. And that's what we see here in the reaction. I have calcium hydroxide at the beginning of my reaction, and at the end I have calcium chloride. So these anions have switched places, just like Betty and Wilma have switched places down here. And so I end up with calcium chloride and then hydrogen hydroxide, which I will call water. Now once I know what I can look at a reaction and predict, and I know what type of reaction it is, I can use this to help me predict products if all I'm given are the reactants. So here's a chart and you have them in your outlines. If I have 2 substances, then chances are I'm going to form 1 compound. If I have 2 compounds and they're ionic, chances are I'm going to form 2 new compounds in a double replacement reaction. So when you see 2 substances, it could be if it's 2 substances, an element and a compound, then that's going to be a synthesis reaction. If you have two compounds, chances are that's going to be a double replacement reaction. If I have one compound, then that's always going to be a decomposition reaction. If I have an element in a compound, that's always going to be single replacement. And then my elements could either be metals or nonmetals. So I can use my understanding of the different reaction types to help me predict products. For example, if I have potassium iodide and silver nitrate, well, those are two compounds. So that could fit into the schematic of a double replacement reaction. So that would be, my products would be potassium nitrate and silver iodide. Let's see if that works. So I write the formula for potassium iodide, which would be Ki. I write the formula for silver nitrate, which would be AgNO3. And then I do the double replacement. And I will have potassium nitrate and silver chloride. And so I predict that if I'm given potassium iodide and silver nitrate, this will most likely be a double replacement reaction forming potassium nitrate and silver chloride. I have to do it in the lab and see what happens, but that's what I predict. Alright, so practice problem. Magnesium bromide and chlorine. Well, that looks like a compound and an element. So if I look at my list, if I have a compound and an element as my reactants, chances are this is going to be a single replacement reaction. So I would predict that I'm going to have a new element, which will be probably bromine, and a new compound, which will be magnesium chloride. So let's write our reactant, our chemical equation. So first I have magnesium. It's an alkaline earth metal, so I know it's 2+. And then I have bromide, which is a halogen, so I know it's minus. So the formula is going to be MgBr2. So my reaction will start out with MgBr2 plus chlorine. Chlorine is an element. And I can't write it like this because I know that chlorine will always bond with itself once. It's a Brinkelhoff element, so it's going to be Cl2. Now I am predicting that this will be a single replacement reaction, so I need to form a new compound. So my new compound will be made out of magnesium and chloride ions. And so the formula for that will be magnesium chloride. So I'm going to form magnesium chloride. And my new element now will be bromine. Bromine is the Br in Brinkelhoff, so I need to do a subscript of 2. I'm going to check and see if my equation is balanced. 1 magnesium, 2 bromines, 2 bromines, 2 chlorides, 2 chlorines. I'm set. So I can use my understanding of the 4 different reaction types to help me predict what products will be formed when I'm given particular reactants.